All right, so welcome back to the part 3 of this hypothesis testing series. So now let's have a look on how we can answer this question here. This is a one-tail test question, and I'm going to be showing you there are two ways you can do it. One is using what we've learned so far in video number 1 and video number 2, which is finding the critical region and seeing whether or not the value falls under the critical region. Or secondly, we can use the value that they provide us and to find the probability and then comparing the probability with the significant level that they're given us. So let's read this question and take out key information that is going to help us on answering this question here. So the question says the standard treatment for a particular disease has 2/5 probability of success. A certain doctor has undertaken the research and produced a new drug which has been successful with 11 out of the 20 patients. The doctor claims the new drug is an improvement than the standard treatment. Treat a 5% significant level, the claim made by the doctor. So now let's read this, using this information here, let's try to make some notes. So I know that X is binomially distributed with my N being 20, given that I'm using with 20 patients, and I'm going to put comma P. I'm not sure what my probability is at the moment, so I'm going to leave it like that. So the doctor says the current medicine has a probability of success of 2/5, which is 0.4. So that's my null hypothesis, is what I expected to be true and what I still believe is true. My alternative hypothesis is going to be what, guys? My P, the doctor says there's been an improvement, that the new drug has an improvement over the standard treatment. And therefore, what I can say that my alternative hypothesis, we are testing that my P is greater than the 0.4%, or 0.4, which is the probability. So now using this information, I need to answer the question. So I'm going to be using two methods to answer it. So you have the option to pick whichever one you prefer in the exam, unless the question restricts you and you have to use either one of the method. So again, as I said, you always assume that H naught is true. So assume H naught is true. So therefore that means my X is binomially distributed where N is 20 and my P is equal to 0.4. So I'm going to be doing two methods. So method number one. Method one is what I'm going to do is I'm going to use the number that they give us, which is 11 out of the 20 patients were successful. I'm going to use the X value that they give me to try to calculate this from there. So in this case, that is going to be my probability that the test is successful for 11 or more people. So X is greater than or equal to 11. And if this is the case, then that gives me what? 1 minus probability that X is less than or equal to 10. So that's what I'm doing here. So if I put this on my calculator, that gives me 1 minus probability of X is less than or equal to 10. It gives me a value of 0.8725. If I put these values, that gives me 0.1275, which is essentially 12.75%. So we can see that my 12.75% is greater than my 5% significant level. So therefore, what I can say, therefore, not enough evidence to reject H naught. So the new drug is no better than the old one. Okay, so this is how you would answer this question here. We calculate the probability given using the value of X that they give you. And then once you get the value, you compare that value with your significant level. As I said, remember guys, the small little diagram I'm going to draw here. We want to calculate the top 5%. So if the probability that we calculated was 5% or less than the 5%, then we would have said we can reject H naught. But because now this probability is to top 10%, 12.75 in fact, which falls here, that's your top 12.75%, we can see that does not fall in the critical region, and therefore we do not reject H naught. All right, so I'm going to delete this now, and I'm going to be showing you on how we can do this using our method 2. So method 2, let's change color maybe to make it different. So our method 2, how we are going to do this. Method 2 is about using the critical value, finding the critical value, and we're going to be using the critical value and compare it with the number 11 that we have here, and that will tell us whether or not it falls in the critical region. So how does it work? It's a bit of a test and trial, right? We need to, because it's one tail test, we need to find the first value for why the probability is less than the 5% significant level. So let's try to do that. I can calculate the probability that x is greater than or equal to 13, let's say. And if I do that, that becomes 1 minus probability x is less than or equal to 12. And if I do this, then that gives me a value of 0.021. And I can see this is a number that's low enough, but I need to test, okay, so if I decrease the value, does that still fall under the top 5%? So if I do probability that x is greater than or equal to 14, not 14, I meant to say 12, then that gives me 1 minus probability that x is less than or equal to 11, and that gives me a value of 0.0565. So I can clearly see that 0.0565 is greater than the 5% significant level, because 5% significant level is 0.05, and therefore I know that 12, it can't be my critical region. So my critical region, in this case here, is going to be when x is greater than or equal to 13. So now, if I draw my graph, so in my graph, what I'm going to see, so my critical region is 13. So if the value is 13 or greater than 13 all the way up to 20, so if the number is 13 or greater than 13, then that falls in my critical region, and this is where you reject H naught. Okay? However, the value that I calculated is 11, so 11 falls under here. So because 11 falls under here, that is not in my critical region, so therefore we do not reject H naught. So do not reject H naught. And that is when it falls under this region here. Okay? So this region here, you do not reject H naught. Sorry, all the way up to here. Anything less than 13, not including the 13, you do not reject H naught. And from 13 equal to 13 or greater than 13, we reject H naught. And always remember to put the context. And here the context is that the new drug is no better than the old drug. Okay? So hopefully this is clear, and this gives you a great perspective on how to answer both sides of the question, in terms of you can calculate the probability and compare the probability with the significant level. And if it's greater than significant level, then we accept the H naught, because we meant to say there is not enough evidence to reject H naught, and therefore that means you're accepting it, and put the context. Or the alternative way is find the critical region. Hopefully you find this useful, and the next video will be on how to do this when it's two-tail. So I'll see you in the next one.